What's going on, everybody? This is Mr. Diamond, and this is just going to be a very brief introductory video into Chapter 5, Chemical Equations. Now, this first section of it, I know we just did a test pretty recently, or at least you should have whenever this video is out. You haven't taken the test yet, and when I'm recording this. Anyway, this first section should be review for most of you. We're mostly going to be focusing on balancing reactions or balancing equations in this first section here. So for section 1, we got equation basics. And in real life, identifying just single atoms or single elements, like looking at them and saying, oh, well, that's an iron, and then that's 2 chlorines, so that means iron must have a 2 charge, so iron 2 chloride. Bam, got it. That's not really the most useful thing to do either. Looking at just atoms isn't super useful, and looking at just compounds usually isn't super useful. Mostly what we want to do is we want to apply them to chemical equations, symbolic representations of the changes that occur between chemical elements or compounds. Chemical equations can be broken into 2 sides. There's reactants on the left. These are the things that you start with. They are the things that are reacting. They are changing. And then on the right side, you have products, the things that you end the reaction with, the things that are produced. For example, we have a very basic one right here. H2 plus O2 gives H2O. The left side would be the reactants. The right side would be the products. You are reacting hydrogen and oxygen together, and you are producing water in this case. Just like our formulas, though, they have to be giving correct information, and they also must be balanced. But instead of just balancing charges, we are going to balance the elements. And this is where I said, hopefully some of you have already had experience with this. I believe you've talked about this in a previous science class. Balancing equations is using coefficients, or the numbers out front, to attempt to satisfy the law of conservation of mass and matter in a chemical equation. Every equation you write in class must not have more atoms or elements on one side than on the other. So for example, in this reaction right here, NaBr plus Cl2 gives NaCl plus Br2. This side has 2 chlorines, and this side has 2 bromines, whereas this side only has 1 bromine, and this side only has 1 chlorine. So based on what's written right here, this would actually be violating the law of conservation of mass and matter. We would be destroying an atom of chlorine and making an atom of bromine, and that's not what happens. So instead, we need to go through. We can't touch any of the elements that are in here. This is the reaction. It's NaBr's, Cl2's, making NaCl's and Br2's. All we can do is add numbers out front here so that we can change what the values are, what the amounts of these things are, to get them to be balanced. So in a problem like this, it's pretty straightforward. You would look and you'd say there's 1 Na, 1 Na. There's 1 Br and 2 Brs, so let's put a 2 out here. And then I would also need a 2 in front of this NaCl, and that would give me 2 Nas, 2 Nas, 2 Brs, 2 Brs, 2 Cls, and 2 Cls. But I'm going to do these on paper so you can see it a little bit more clearly. That'll be in the attached video. But this is all we're doing the first day. The first worksheet is just dedicated to balancing these equations. I hope that makes sense to everybody. If you have any questions, please send me an email. I know this is pretty straightforward, a very short video, but like I mentioned, this is the day after the test. We want to go a little bit easy on you. In the meantime, though, have a great rest of your day, everybody.